This is a review of what we have learned so far about ellipses. Please put your pencils and pens down. Do not copy off of me. Go back and do it yourself once I show you how to do it. Look at problem number 1. We're supposed to graph these and find the key information. This is clearly an ellipse. You see the x and y is squared, but yet the coefficients are not the same, so you know it's going to be an ellipse. Alright, let's go ahead and put this in standard form. This has to be 1 over here on the right hand side, so let's divide both sides by 1,600. Okay, how many times does 64 go into 1,600? Okay, apparently it goes in 25 times. Okay, great. So this is going to be x squared over 25. That means 25 must go into 1600 64 times. So this will be y squared over 64 equals 1. Now, this is our a squared and b squared. A is always the bigger number. So this right here tells me that a is 8. Now first of all, the center is 0, 0. I know that because it's just x squared and y squared. It's not like x minus 3 squared or something like that. Alright, so it's just x squared and y squared, so that's 0, 0. So we should graph that as a matter of fact. Alright, the center is 0, 0. Now, the a value, so I'm going to go 8. Now the a value came from the y's, so that means I will go 8 in the y direction, up and down. So I'm going to have 8 here and 8 here. Alright, these are my vertices. So my vertices are 0, 8 and 0, -8. Now I'm going to do the co-vertices. Alright, the smaller value gives me the b value for the co-vertices, and that's going to be 5. Because it's with the x's, then I will do my 5 in the x direction, left, right. So I will go 5 to the right and 5 to the left. So right there, that shows you where the ellipse lives. Whoa, that was bad. Okay. I can do that a little. Whoa, erasing the whole thing. That's great. Alright, that's a little better. Anyway, that's the best I'm going to do. So the co-vertices are -5, 0. And 5, 0. Now the foci. Okay, I've got A and B. I'm going to need C for the foci. So we know that C squared is equal to A squared minus B squared. That means C squared is equal to 64 minus 25. Okay, so that means C squared equals 39, and if I take the square root of both sides, let's see if anything will actually happen. Alright, so that doesn't simplify, so it's just the square root of 39. Okay, which is approximately 6.2, by the way. So that tells me that C is equal to the square root of 39, which is approximately 6.2. Now, you will not see any decimals in my answer here. I'm just going to use the 6.2 to help me graph it. The foci always go the long way. So 6.2 is going to be about here, and if I go 6.2 down, that's here. So those green dots are my foci. Now, as far as naming them, these foci are on the y-axis. So that means the x value is 0. So it's going to be 0, comma something. So it's just the y value. I'm not allowed to use the decimal. I have to be exact. So I'm going to use the radical form. So if I'm going up, then that's positive radical 39. If I'm going down, that's going to be negative radical 39. All right, so those are the foci. Now the major axis is just the long way from end to end. All right, so remember how we graphed it. You know, it's 8 and negative 8, so that's a total of 16. And then we had negative 5 and positive 5, so the minor axis has a length of 10. Okay, that is it for number 1. All right, looks like they're going easy on us in problem number 2 because you're given the standard form up front. Okay, so the center is going to be positive 3, comma, positive 1. All right, it's the opposite of these. So there's my center. We should go ahead and graph that. So 3, comma 1 would be right here. All right. Now, the bigger number is going to be our a value. So this is a squared, so that means a must be 6. Okay, that'll help me find the vertices. Okay, now notice that the 6 is coming from the y side of the equation. So I'm going to go 6 in the y direction. Now, starting from the center, I'm going to go up 6 and down 6. Okay, so if I go up 6, I'm going to wind up here at 7. If I go down 6, I'm going to wind up here at negative 5. So these are my vertices. So that is 3, comma 7. And 3, comma negative 5. All right, now it's time for the co-vertices. Well, this is going to give me my b value. All right, so if b squared is 1, then b must be 1. Square root of 1 is 1. Since that's with the x part of the equation, I know this will be a left and right one, like this. So those little guys are my co-vertices. So 2, comma 1 and 4, comma 1. Now the foci, or foci, whichever way you want to go with it. The foci will come from the c value. And we know that c squared is equal to a squared minus b squared. So that's 36 minus 1. C squared is 35, so that means c is equal to the square root of 35. Now I don't think this simplifies, but I'm just going to be extra sure. All right, it does not simplify. However, the decimal is close to 5.9. Do not use the 5.9 in your answer, but you should use it to graph with. Obviously, we're going in the y direction here. The foci always go the long way. So 5.9 would be like right here and right here. Wait, I lied. I missed. Okay. 5.9, because I was thinking 5.9 looking at the 6, but is 5.9 up. All right, so that's going to actually be like right there and right here. Okay, it's almost to the vertices. Anyway, the coordinates of those points. So you got to be careful, guys. The x value of these two green points should be obvious because they are both on this line of x equals 3. So the x values are both 3. So I'm going to have 3 comma something and 3 comma something. It's the y value that we have to worry about, up and down. Now, we are going to use this c value of radical 35. Okay? Now, but it will not just be plus radical 35 minus radical 35 like we did when the center was 0, 0. Okay? The y value here is 1. Okay? Here we are at a height of 1. So starting from here, if I go up, I'm adding radical 35. If I go down, I'm subtracting radical 35. But remember, I'm starting from an initial y value of 1. So we're going to say 1 plus radical 35, all right, to show that we started at 1 and then we went up radical 35. And then the other one will be 1 minus radical 35. That shows that we started at a y value of 1 and we went down radical 35. Going down is subtracting. So this is how you would have to write the foci. Okay? Now, the major axis is simply the long way across. So remember the a value and the b value? The a value was 6, so we went up 6 and down 6. That's a total of 12. The minor axis, the b value was 1. Left 1, right 1, that's a total of 2. So the major axis will always be double A, and the minor axis will always be double B. So that's it, except for drawing the actual graph. Kabam! It's going to look something like that. All right, take a glance at number 3. We're just supposed to write the standard form equation. Well, we've got the center is right here at 2, 2. So that makes it a little bit extra easy because we don't even have to worry about which is the x and which is the y. But because the center is 2, 2, the opposite of these will give us x minus 2 squared from the x value, and then y minus 2 squared from the y value. So that gives you the top half. For the bottom half, this is going to be our a and b value. Okay, so I'm talking about this, guys. If I look the long way here, from the center to the edge, that's 3. So that's our a value, okay? So I'll put this right here. So I know that a is 3, which means that a squared is 9. Now, so that means this 9 is going to be one of the denominators. Do you know if it will be the x or the y denominator? It'll be the y because this is up and down. It's vertical. That's a y situation. So the 9 goes right there. Now, looking the short way, look for the b value. You will find the b value right here in green. All right, and that's 1. So that means b is 1, so guess what? B squared, also 1. So that must be the other denominator. And that's it. That's all there is to it. All right, let's move on to number 4. All right, looking at number 4, we are supposed to classify this and write the answer in standard form. Now, if both of the variables are squared, it's either going to be a circle or an ellipse, okay? Because for a parabola, only one of these would be squared. Now, the way you know the difference between a circle and an ellipse is if the coefficients are the same, then it's a circle. You can imagine the balance of a circle and the way it's the same in both directions. So the coefficients have everything to do with that. So if the coefficients are the same, it's going to be a circle. But if the coefficients are different, then it's an ellipse. So this is going to be an ellipse. All right, now let's go ahead and get this into standard form. So for standard form, we need to complete the square. So we're going to get our x's together. So that's going to be 25x squared minus 50x. And we need to get our y's together. So that's going to be plus 9y squared minus 90y. And anything else needs to get out of the way. So minus 25 on both sides gives us negative 25. So now we will complete the square, but be careful. I'm not going to do half of 50 and square that. I'm not going to do half of 90 and square that. When you have a number in front, you have to factor that out. Okay, so I'm going to bring this 25 way out in front of the parentheses. Now, when I do that, to find out what goes inside, you divide. So I should have left more space. Hold on. Okay, so I'm bringing this 25 out front. Okay, and I'm going to bring this 9 out front as well. Okay, so to find out what goes inside, I have to divide. So I am dividing by 25 on these. And I'm bringing the 9 out here, so that means I'm dividing these by 9. So that is going to leave me with x squared minus 2x. And I left a space to complete the square. And over here, this is going to leave me with y squared minus 10y. And I left a space. So, of course, I left a space so I could complete the square. Half of 2 is 1. 1 squared is still 1. Now, you know how we always have to add this to both sides, and that's a common mistake? Well, I'm going to add something to this side, but it won't be a 1. The reason why is not really a 1. This is really 25 times 1. If you do the distributive property, which is what this is set up for, this is really a stealth 25, because 25 times 1 is 25. So to balance it out, I really am going to have to add a 25 over here. Okay? Similarly, yes, half of 10 is 5, and 5 squared is 25. But again, I'm not going to add 25 over here, because this is really 9 times 25, which is a secret 225. So if I want to balance this out, I'm actually going to have to add 225 to both sides. Okay? So you'll notice that these are going to cancel out. All right? So that is going to give me 25 times x minus 1 squared, okay, plus 9 times y minus 5 squared is equal to 225. Okay? Now, this is trying to be an ellipse, like I said. So that means for standard form, I need a 1 over here. So I'm going to divide everything by 225, like so. Okay? Okay, 25 goes into 225 9 times. So when I rewrite the equation, this is going to become x minus 1 squared over 9. All right, that means 9 must go into 225 25 times. So I will have y minus 5 squared over 25. And of course, that is equal to 1. So we were supposed to write each equation in standard form, all right? That was our objective, and we did that. All right, taking a look at number 5. This is going to be another ellipse. All right, so I guess we're supposed to say that. Ellipse. Again, if the x and y are both squared, I know it's either going to be a circle or an ellipse. If the coefficients are different, it's an ellipse. All right, it's lopsided. If the coefficients were both the same, that would make it a circle. Anyways, we need to combine these x values. So that's going to give me 4x squared minus 8x, and then do the y values. So that's plus 9y squared minus 36y. All right, let's get this 4 out of there. So that's going to equal negative 4. Now, the x squared and the y squared both have a coefficient. So that's going to have to be factored out. So I'm going to bring that 4 out front. And that's going to leave behind x squared minus 2x. All right, I am going to leave a space here. Let's pull out that 9 as well. And that's going to leave behind y squared minus 4y, leave a space, equals negative 4. Okay, time to complete the square. Half of 2 is 1. 1 squared is 1. Am I going to add a 1 over here? Oh no. This is not really 1. This is really 4 times 1. This is really a 4. So I'm going to add a 4 over here. Okay. Now for the 9s. Half of 4 is 2. 2 squared is 4. Am I going to add a 4 over here? This is not really a 4. This is 9 times 4. This is 36. So I'm going to add a 36 over here. Now, of course, these will cancel out and just leave 36. So completing the square gives me the same thing twice. So this will be x minus 1 squared. All right, and it'll be 9 times y minus 2 squared is equal to 36. Now, this is trying to be an ellipse, and for the ellipse standard form, I need a 1 over here. So I'm going to divide both sides by 36. Okay, 4 goes into 36 9 times. 9 goes into 36 4 times. So that's why this equation is going to become x minus 1 squared over 9 plus y minus 2 squared over 4 is equal to 1. And that would be the standard form that we were asked to find. So that's number 5. Let's take a look at number 6. Write the standard equation for the ellipse given the characteristics. Okay, so we have the vertices and the co-vertices, and let's go. We know it's an ellipse. So right away, we can begin to set up our equation. All right, we know it's going to be like this. Okay. All right. A diagram will help me. So let's see, I've got -2, comma, -3. All right, I'm going to put a little graph. In fact, okay. All right, so 2, comma, -3 would be like this. 2, -3. Okay, so there's a vertex. And then I've got 2, comma, 7. So 2, comma, 1, 2, 3, 4, 5, 6, 7. Okay, these are my vertices, all right? 2, comma, -3, and 2, comma, 7. The center is going to be halfway in between these two. So look at this. This is 7 up, and this is 3 down. That's a total distance of 10. So if I go halfway, that will be 5 down or 5 up. So let's see. If I go 1, 2, 3, 4, 5, that puts me right here. This is the halfway mark. This is 2. 2 is halfway between 7 and -3. Okay, so that makes this actually then the point 2, comma, 2. All right, it's over 2 and it's up 2. So this, my friends, is the center. That allows me to write the top half of my ellipse equation, doesn't it? Okay, so x and y, we do the opposite. So that means x minus 2 squared and y minus 2 squared. All we need is a squared and b squared. Well, look here. The distance between the center and a vertex, that's going to be my a value. A value. I'll just use this color. So from here to here, all right, that's from 2 to 7. That gives me an a value of 5. All right, from 7 minus 2 is 5. So my a value is 5. And if a is 5, that means a squared is 25. Oh, by the way, so I'm about to have a 25. So a is 5, which means that a squared is 25. Is this 25 going to go with the x or the y? Well, you see this is vertical, okay? It's up and down, so that's a y situation. So the 25 goes here. Now, what I need is a b value. For that, I will use green. Okay, b value. So that's going to come from these co-vertices. One co-vertex is 0, comma 2. All right, that gives me what I need right there. The other one is 4, comma 2. Okay, but anyway, the b value is going to be this distance right here from the center to the co-vertex. So this tells me that b is 2. All right, it's going from 0 to 2. That's 2, which of course means that b squared is 4. Clearly it's going to go with the x because that's the only one left, but also because it's horizontal, that's the x direction, so it goes with the x. That is all, my friends. That's how you do number 6. Okay. Let's see, am I skipping anything? 5, 6, 4. All right, I guess I did. All right, last one. Solve the following systems of equations. Well, whenever you do systems, either you're doing substitution or you're doing elimination. Elimination is the one where you set them equal to each other and try to cancel stuff out. I don't see any variables that are the same, So the setting them equal to each other thing, that doesn't look like it's going to work. So substitution is the way to go. So let's do that. For substitution, you need to take one of the equations and get a variable by itself. So for example, let's look at this equation. Okay, I'm going to move it over. So I've got x minus y is equal to -6. Okay. If I get y by itself, like I often do, so I would subtract x from both sides. So that's going to give me -y is equal to -x minus 6. So dividing everything by -1, I'm going to have y is equal to x plus 6. Okay, so that's pretty cool. So y is equal to x plus 6. So that means I can take this and plug it in to the other equation. So this is what I'm talking about, you guys. I'm going to take this x plus 6 and I'm going to put it right there where the y goes. So that's going to make this equation become, all right, I've got x plus 2 squared, right there, plus. Now here comes the y part. Just for a second, I'm going to put it in pink. So instead of y, I'm putting x plus 6, right? That's the y. Now I'm switching back to blue for everything else. So I still have the -2 squared equals 4. So hopefully you can see that the only change I made to this equation was I erased the y, and instead of having y minus 2, I have x plus 6 minus 2. Okay, so this is going to quickly become x plus 2 squared plus x plus 4 squared, right? Because -6 plus 2 is 4. Now, we're going to have to multiply all this out. So I'm going to have x plus 2 times x plus 2 plus x plus 4 times x plus 4 equals 4. All right, I'm running out of paper. If I multiply this out, I will have x squared plus 4x plus 4. All right, that's from that part. And over here, I'll have x squared plus 8x plus 16. All right, if I do the double distributive property. All right, let's see if I have more space over here. I believe I do. Combining like terms. And you know what, while I'm at it, I might as well move that 4 over as well. So I've got x squared plus x squared. So that's 2x squared. Okay, maybe I should highlight these as I go. So I just did x squared plus x squared. Now let's do, all right, so I've got 4x and I've got 8x. All right, so that's going to make 12x. Okay. And last but not least, I've got 4 and 16 and -4. Well, actually, the 4 and the -4, they cancel out. So I'm just going to have 16. So plus 16 equals 0. I'm noticing that all of these are divisible by 2, so that's going to give me x squared plus 6x plus 8 is equal to 0. I just divided everything by 2. Now, hopefully this will factor. X squared is x times x. 8, well, that could be either 2 times 4 or 1 times 8. Let's go with 2 times 4. Inner, that gives me 2x. Outer, that gives me 4x. If I just leave them positive, that will give me 6x. All right, and a positive 2 times positive 4 is positive 8, so it works out. Setting both of these equal to 0, gives me x equals negative 2 and x equals negative 4. Now these are not my final answers, mind you. I still need the y values that go with them. Let's see, maybe I can squeeze that in here. T-chart time. So I've got x's and I've got y's. My x's, you understand, are negative 2 and negative 4. I need the y values that go with them, but I have a y machine somewhere. Oh, it's right here. Y equals x plus 6. I like the y equals part because it tells me what y equals. I'm going to use that. So y equals x plus 6. So for this problem, that means y equals negative 2 plus 6. Well, gosh, that's 4. And here, that means y equals negative 4 plus 6. And that's 2. And that's it. So that means my solutions, my final answers, which I'm going to have to put up here because I'm just plumb out of space. I could squeeze it in. Should I squeeze it in? Maybe if I change colors, it'll be okay. So my final answers are negative 2, 4, and negative 4, 2. And that is it. I feel myself hitting the bottom of this paper, which means I have reached the end of this video. I hope it was helpful, and I hope you didn't copy off me too much with your pencils and pens. Make sure you can do all of these problems by yourself, people, and you won't have so much studying to do before the next test. All right, see you on the next video, guys.